Hey there guys, today we are going to be talking about applying what we've learned about linear equations to real life problems. Bless me, sorry. Okay, let's go ahead and get started. There's two examples we're going to talk about today. Alright, our first example, we're going to start off with an example, so go ahead and pause, title, and write down that essential question. Okay, so our first example is the amount Y in gallons of gasoline remaining in a gas tank after driving X hours is Y equals negative 2X plus 12. Again, this is a negative 2 because the gas tank is using gasoline. Okay, we're going to graph the equation, and here's what I need you to be focusing in on is that when you're talking about real life problems, you're talking about interpreting. So we're going to be talking about interpreting X and y-intercepts and the slope as well, okay? And then we're going to predict off of that graph that we have how much is left after 5 gallons. So let's go ahead and part A, and we're going to graph it. Let me get my nice tools out. Graph it. Okay, since I'm sketching my graph and I don't have the tick marks, I'm going to have to include tick marks on my graph. Hopefully you're using your graph paper notebook and you won't have to include your tick marks. And I'm going to have to go to 12 because this is, again, my y-intercept's at 12 and my slope is down 2 over 1. So I'm going to go by 2s, so I need to label that 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. So this is negative 2, and this is 2. Okay, I'm going to go by 1s in my x-axis. They don't have to go by the same number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The biggest reason I'm going by 1s with my x-axis is because I fall 2 and I run 1, and my slope, if I'm running 1, it's easier if I go by 1s. Okay, so 12. So x-intercept's at 12, and then I fall 2, so this is a jump of 2 because I went by 2s, and then this is over 1 about here. Okay, I fall 2 because this is a jump of 2, and I run 1. I fall 2, run 1, fall 2, run 1, fall 2, run 1, fall 2, run 1. Okay, so that's my rough sketch. Yours can be completely straight. You should be making a complete straight line. Obviously I didn't because I did this by sketching it. Okay, now, there we go. We're going to interpret our x and y intercept. So our y-intercept is at, it's right here, here's our y-intercept, and it's at y equals 12. And so what does 12 mean? Y equals 12. Y represents amount gallons in a gasoline tank after a drive in X hours. So there's 12 gallons in the gas tank. That's what Y represents, 12 gallons. Sorry, I'm going to abbreviate in tank. At beginning, at start. At start. Okay, X is right here. Hopefully I got a good x-axis intercept. So 1, 2, 3, 4, 5, 6, 7. X equals 7 is how many hours it took for there to be no gasoline left. Hours it takes to use all gas. Okay, there we go. Interpretation. Talked about those intercepts in terms of the problem. See, after how many hours are there 5 gallons left? So I'm going to use 2, 4, right about here is 5. I'm going to predict off of my graph how many hours that it's going to be And it's going to be in between 1, 2, 3, 4, 4, and 5. So part C, I'm going to say in between 4 and 5 hours. Oops, sorry. 4 and 5 hours. Part C. Yours should have a much better estimate. So tell me how close I got with my little sketch. 4 to 5 hours until there's 5 gallons left. All right, remembering this y-axis is your gallons and this x-axis is your hours. All right, let's go ahead and go to example 2. Example 2. Okay. The graph shows the height y in feet of a flag x seconds after you start raising it up the flagpole. So the height in feet, so this is height in feet for y, and x is seconds. X is seconds. So I'm just going to label that so I can keep track of what unit goes to which axis. Interpret and find the slope. So they go from 3 to 6, so this is rise 3, run, these are going by 2s, sorry, 1, so 1, 2. Rise 3, run 2. Okay, so what does that mean? That 3 feet for every 2 seconds is how much the flagpole rises. So 3 feet every 2 seconds is how much the flag rises. You can say even speed for this is the speed at which the flag rises. Okay, write an equation for the line. So the intercept is at 3. I'll put part B down here. The intercept is at 3, so y equals plus 3. The slope is 3 halves x. Okay, there we go. What is the height in the flag in 9 seconds? So we can go, but our graph doesn't have it on here, so we can't even estimate on our graph. If it was on here, we could. So we're going to plug 9 in for x, because x is seconds. 3 halves times 9 plus 3, and this is part C, okay, is equal to y, how much it rises. Okay, 3 times 9 is 27 plus 3. Okay, now I'm going to go over here for more space. Sorry, go over here. All right, 27 over 2 plus, I'm going to change it so they have the same denominator. 3 times 2 is 6 over 2. 7 plus 2 is 27 plus 3. Oh my goodness, what am I saying? 27 plus 6 is 33. 33 divided by 2 is, it is 16.5 feet in 9 seconds is how high our flag would be. So that would make sense. If we got to 9, it would be somewhere over here. That would make sense. Okay, great. Let's go ahead and start those on your own problems. There's only one today. Okay, when you're ready to check your answers, go ahead and hit that play button. Thanks, guys. All right, here's what we should have gotten. So you wrote the equation, so y equals 20x plus 5. Interpret the intercept. You didn't even have to graph it. Or interpret the intercept. 5 is the allowance you started off before mowing those lawns. And then how many lawns do you need to earn enough money for the MP3 player? You would plug in 125 into your equation, and then you will get 6 lawns. Alrighty, go ahead and answer that essential question and take that checkpoint. I hope you guys are having a good night, and we'll talk to you later.